I'm going to ask you some brief and easy questions, general questions, to help our Chinese investors better understand how NuCypher works. So my first question is, can you please tell us briefly what NuCypher is about and what NuCypher trying to achieve?
Sure. So NuCypher is a data privacy layer for blockchain and decentralized applications. So we give developers a way to store, share, and manage private data on public blockchains, or more specifically, file systems like IPFS and Swarm. So for example, if you are building a medical records application on top of Ethereum and you want to store patient records on IPFS, you need some way to have those be private, confidential, and encrypted, but then still have those encrypted records be shareable with like a doctor or a hospital or some valid recipient. And this is the access control infrastructure that basically we're providing with NuCypher.
Is there any existing solution that can solve this, or
not for decentralized applications?
Oh, really?
So the alternative, if you were using, let's say you wanted to build a medical records app on top of Ethereum without NuCypher, the way you would probably do it is either you would have to share the private key for the encrypted record with the doctor, whoever you want to share it with, which obviously isn't secure, or you'd have to download the data, decrypt it, encrypt with the recipient's public key, and send it to them, which obviously is like very clunky. So with NuCypher, it makes it a lot easier and more performant and secure as well.
So our next question is about, because we are recognized that NuCypher is issuing SEO, so we want to know like what do investors get in return for this program?
Yep. So people who participate or who hold the token, the function of the token is for staking. So if you stake the token as a kind of collateral or security deposit, that gives you the ability to run a node for the NuCypher network. So you provide this re-encryption service or this access control service to the network or to users of the network. And if you do that, then you get paid by users of the network in fees in ETH, and you also participate in the inflation schedule of NuCypher. So you'll get NuCypher tokens as well.
Oh, you get NuCypher tokens?
Yeah, so if you're staking the token and running a node, then all the inflation goes to the people that are staking.
So is that just a POS system? That's the
sort of proof of stake, yeah. So we use proof of stake as a way to allocate work, to allocate mining rewards, and also as a way to ensure that the nodes are behaving correctly. So if you stake and you run a node, but you are malicious or you go offline or you don't do your job, then your stake will get slashed.
So does using NuCypher consume any token?
No.
Oh, okay.
So if you're just a user of the network, let's say you're building a medical records application, you pay fees to the network in ETH, or in the future potentially some sort of stable coin. So the token is specifically for people who want to run a node, stake it.
Okay. But that's just the kind of the supply side of, let's see, that's the supply side of the token, right? Like how do you really create a demand in the so-called token economy?
Well, so if the network is getting a lot of usage, you want to run a node because you get paid in ETH for that.
Oh, okay. So that's how you incentivize them.
Correct. Yeah. So you'll stake the token and you're incentivized to run a node because you'll get paid fees by users, but just not in our token in ETH, and you'll also get new NuCypher tokens.
Okay.
So it's almost like an analogy might be like a taxi medallion. So if you have a taxi medallion, that gives you the ability to give people rides in a taxi and make money from doing that.
I see. How hard is it to be a NuCypher node?
So it doesn't require any kind of specialized hardware. So it's not like Bitcoin mining. For small stakes, you could even do it like on a Raspberry Pi.
Oh, really?
What is important is availability. So you want a stable internet connection, and probably some sort of uninterruptible power supply. But other than that, like commodity hardware will work. But at least in the early days of the network, it'll probably require some degree of technical competence on the software side to sort of configure and install the node software.
It doesn't consume a lot of power doing encryption, decryption stuff.
Yeah. So the actual computational, proxy re-encryption is cheap computation.
Okay. And our next question is about, we want to know like what's your background and what's the team's members' background?
Yep. So my background is a blend of software engineering and traditional finance. So I worked at Morgan Stanley covering tech and media and telcos on the investment banking side out of university. Came out here, about 5 years ago, was interested in Ethereum and blockchain because it was kind of the intersection of my interest in finance and economics, but also tech and software engineering. My co-founder and our CTO is a physicist and scientist from the Moscow Institute of Physics and Technology, and he was previously working in an area pretty close to like quantum computing and quantum cryptography.
Oh, jeez.
And originally moved to the Valley, was building infrastructure tools at LinkedIn, and then the rest of our team is sort of a mixture of people with backgrounds in either open source software or distributed systems engineering, cryptographic engineering, or in a cryptographer as well.
So who is the chief crypto guy?
So our cryptographer is a guy named David Nunez, who is, was actually one of the leading proxy re-encryption researchers in the world before he joined NuCypher, and he was at the University of Malaga in Spain.
Oh, he's now full-time at NuCypher.
Yes.
Wow. So anybody from the advisory board that you want to comment on?
Yes, we have a technical advisory board, which is mostly like researchers and academics on the cryptography side. So one of our advisors is Giuseppe Atteniese, who's the department or chair of computer science at Stevens Institute of Technology, and he was actually one of the original inventors or founding fathers of proxy re-encryption. So he is one of the authors of one of the early papers.
Wow.
And then our other advisor is Professor David Evans at University of Virginia, who leads their secure computation research group and is one of the leading researchers in multi-party computation.
Wow, amazing. You can remember all those files. I mean, that's hard to me.
Yeah, all the fields. So how about NuCypher's currently, like, who is NuCypher's competitors, and what's the strengths for compare other competitors?
Sure. So in the non-blockchain space, the closest technology would probably be either just traditional public key encryption or like data masking and data tokenization. In the blockchain space, the closest set of technologies would probably be secure multi-party computation. There are, I think, pretty significant differences, but you could use proxy encryption and multi-party computation to achieve similar things around data sharing. Enigma is probably the most high-profile project working on that technology.
So for the next question, so as you have already told us your background about like your previous work experience in financial area, right? So, but currently your project is based in database like
Encryption.
In the encryption, and so we want to know like why do you change your field to like from finance to here?
Sure. So I don't know if it was that big of a pivot. I mean, my background is finance, but also software engineering. So, in blockchain is kind of the fusion of economics and technology and engineering. So I think it just happened to be like a very good fit from that perspective. Okay. And then my co-founder and I have been working kind of. We like to build developer tools. We like to build infrastructure. That's kind of what we previously built and what we enjoy building. And with ZeroDB, we were working on this encrypted database, and I think it was a natural kind of segue into building NuCypher.
All right. So our next question is about like what's the application that NuCypher is doing right now?
So fundamentally, it's just a horizontal piece of infrastructure for anyone that's managing private data in a decentralized application. The early verticals where we've gotten a lot of traction, one has been this healthcare use case, so storing encrypted medical records on IPFS, sharing it with a doctor or a hospital. MediBlock, for example, in Korea is one of the early users there, but we've got many other great projects that are doing very similar things in Europe and the United States. Another vertical has been data exchanges, data marketplaces. So projects like Datum, for example, which are aggregating a bunch of data. It could be browsing history, social media data, genomics data. They're encrypting it, and then they're conditionally decrypting it or selling it in exchange for payment to advertisers or researchers. So they can use NuCypher to say, give this person access to the encrypted data if they pay, let's say, 5 ETH to the data owner's address.
I see.
Another big vertical has been decentralized databases. So NuCypher is the access control layer for projects like Bluzell, Fluence, and Wolk. So they use us to control who can and can't query the database.
They are using.
NuCypher they will be integrating it and building it into. I mean, Bluzell and those projects are still kind of in the process of building their own stuff. But yeah, they'll use us for that piece.
I see.
There's also a lot of interesting stuff around IoT. So like how you can encrypt data going back and forth between edge devices.
Right.
And another great use case is end-to-end encrypted group chats. So proxy encryption is very good for having large group chats that's end-to-end encrypted. It's a very scalable and performant solution for that.
Okay. But for your team, you are basically building the horizontal infrastructure.
Correct. Yeah. So
Not
we're
really
building the
any
protocol.
specific
Yeah.
application.
Right now we're not building any
Are
specific.
you
application.
considering building any demo application at least to, or some developer kit?
Potentially in the future we would do something like that,
Uh-huh.
but not in the near to medium term. And we have enough of these projects that are already building on top of it. There'll be, I think, a lot of examples pretty soon as we got launched on mainnet.
I see. How is it progressing?
Very good. So we launched Pi Umbral a couple weeks ago, which was the underlying crypto system that we're using. We'll have everything running on Ethereum testnet in the next several weeks, so probably the first half or sometime in April. And then for mainnet, the current ETA for that is sometime in the summer.
Actually, this question might be a little bit similar to the competitor thing. So when I first learned the proxy re-encryption, it's like, wow, that's a really super cool idea. I mean, this like how you really can do this decryption of A and encryption using B in an atomic way, because you're gonna have that text, non-cipher text in between, right? And also, if this is really kind of, I mean, you said it's already published in the paper. If it's really easy to get into this area, why nobody have ever thought about this?
So I would say it's easy. Like our team is a lot of like distributed systems engineers, cryptographers, cryptographic engineers. So these are all like very difficult fields. You need a lot of sort of both scientific and research, but also like engineering competence to do it well, and to implement these cryptographic systems in a secure way. So I wouldn't say it's easy. I think the reason why no one has previously done proxy re-encryption is because proxy re-encryption is most useful in patterns where you have like one-to-many data sharing. So if you're just doing like one-to-one communication, traditional public key encryption works very well.
Yeah.
But one-to-many or many-to-many is where proxy re-encryption adds a lot of value. And more recently, a lot of these distributed systems like big data platforms, cloud, blockchain, IoT, are characterized by this many-to-many data sharing pattern. So I think the benefits of proxy re-encryption are more recently kind of it's needed now that these distributed systems are becoming more popular.
Do you want to give a really brief explanation of how this
Brief explanation.
yes this re-encryption works
Yeah.
without me going into the paper?
Sure. So the way proxy re-encryption is just fundamentally a more scalable form of public key encryption. So if you think of public key encryption, traditional public key encryption as being very good for like one-to-one communication. So I have some secret message, I need to share it with you. I can encrypt that message with your public key, send it to you, you decrypt with your private key. It works very well.
Yeah.
But let's say instead of just one person, I need to share that message with a dozen people or 100 people, 1,000 people. I then have to encrypt a dozen, 100, 1,000 times.
Yeah.
Send it a dozen, 1,000 times.
Right.
It scales very poorly. But what I can do with proxy re-encryption instead is I can encrypt the data one time under my key, and then I can delegate and revoke access to that data to as many people as I want. And the way that works is I can use proxy re-encryption to, let's say I encrypt some data, I store it somewhere, it's encrypted under my key. I'm the only one who can access it, right?
Right.
But let's say I need a key has two inputs. One is my private key, and the other is your public key. I'll give this re-encryption key to some proxy, and the proxy can use that re-encryption key to take the data encrypted for me and re-encrypt or re-key or transform it so that it's now encrypted for you, and you can use your own key to decrypt it. So that's at a high level kind of how it works.
So you do have to give your private key to
No, you give
a proxy.
you give the re-encryption key, which
So what is that key then?
A re-encryption key has two inputs. One is my private key, and the other is the recipient's public key. But once
Right.
you create the re-encryption key,
It cannot be
you
reversed.
can't reverse. So it's a one-way function.
Really?
Yeah.
Ah. Oh, okay. That's actually quite straightforward. I mean, yeah, that's
And then that's actually just all like elliptic curve cryptography. The re-encryption is happening.
okay.
Actually, my last question, you just answered. So,
Okay.
my last question is about what's the plan for 2018 for NuCypher? So you just answered some question already.
Yep. I mean, so our current plan right now is we'll have testnet in the next couple weeks. mainnet will be ready sometime in the summer. Hopefully, we'll be in a position to launch mainnet and also do the main sale at that point. And that's when everything will go live, and you'll have a lot of these projects that are currently building against testnet that'll launch as well, like BlueZell and ManyBlock and all of these projects, and obviously get a lot more projects as well, hopefully.
Do you have any announcement you want to make?
Just the testnet is coming very soon, so we should have that in the next couple weeks.
Oh wow.
But if people are interested, we have a Telegram group, which is more general news and announcements. All of our development happens in the open on Discord and on GitHub. So if you're interested in following along there, you can join either of those and sort of follow the project and track it.
Okay. Is the team still hiring?
We are not a ton of people between now and the public sale because there's just a lot of stuff going on in terms of onboarding people. But we are hiring a few roles, and we'll be hiring more after the public sale.
Okay. All right then. I think that wraps up it.
That's all the questions. Thank you so much.
Yeah, thank you guys.
Thank you.